This video is about the mean value theorem, which, contrary to its name, is actually a really nice theorem. This is part of our real analysis series on TikTok, and the mean value theorem is super important for a lot of really different reasons. And if you're new here, this is part of our series where we're learning real analysis on TikTok. Basically what it's saying is if you have a continuous function and you draw a secant line between any 2 points on that graph, if your function is differentiable between those points, then there's guaranteed to be a tangent line that's parallel to that secant line. A common application might be something like this. If this were a graph of position versus time, then the slope of that secant line would represent your average speed throughout your journey. The mean value theorem would say there was some point where your instantaneous speed was exactly that value. Now, how do we prove the mean value theorem? Well, we had this secant line that was like that. And what we could do is we could just roll the picture a little bit so that it was horizontal. Then maybe that would make things easier. And that rolled version of the mean value theorem is actually called Rolle's theorem, believe it or not. And this theorem is actually not too bad to prove. Because as we saw in the last video, any continuous function on a closed interval is going to achieve a maximum somewhere. And if that maximum occurs in the middle, that has to be at a critical point. Since our function is differentiable at every point in between, the derivative has to be 0 at that point, and we're done. Now, there are a few other cases you have to care about, like maybe the maximum occurs at the 2 endpoints, but I'll let you think through those cases because it's actually a really good practice. Now, how do we reduce from the mean value theorem case down to the Rolle's theorem case? We didn't do it by rotating, we actually did it by subtracting. If we take this function f of x, and we just subtract the equation of this orange line here, that will give us a new function whose value is blank minus blank at 0 at this point here. And the value at b is going to be blank minus blank, gets us down to 0 as well. So that function, f of x minus this linear function, is going to have the properties that the value at a is the same as the value at b, and then we're going to be in a position to use Rolle's theorem. If you want to work out the details, it's a really fun exercise because you'll use basically every ingredient in the hypotheses. And finally, I can't resist giving one special application of the mean value theorem. Suppose you have a function that's differentiable, but its derivative is always 0. Well, that means the slope is always 0, and by the mean value theorem, that means all the secant lines have to also have slope 0. And so we've just proved that really interesting fact that you learned in calculus, that the only antiderivatives of 0 are constants.